Geometry Chapter 8 Lesson 4, and we're going to introduce the next two trigonometric ratios, the sine ratio and the cosine ratio. You remember from our discussion in the previous lesson that these trigonometric ratios are a comparison or a ratio of two legs within the right triangle, and within the right triangle that ratio remains constant no matter what the lengths of the legs are. That ratio always is the same, and because that value never changes, it allows us to then determine the length of one of the legs if we're missing one, or if we know the legs we can determine the angle because these values remain constant. So the sine and cosine ratios again are just a ratio of a pair of legs within the triangle. We're just going to need to know what that ratio is so that we can then apply it and determine the lengths of the missing leg or the measure of the missing angle. The tangent ratio was a ratio of the opposite leg over the adjacent leg. The sine ratio is the ratio of the opposite leg and the hypotenuse. So we're using the hypotenuse when it comes to sine instead of the adjacent leg. So the tangent ratio had the adjacent leg in the denominator. The sine ratio has the hypotenuse in the denominator. So the sine of any angle is equal to the opposite leg over the hypotenuse. Okay? The cosine ratio uses the adjacent leg and the hypotenuse. So this one is similar to the hypotenuse because it has the same denominator. No, similar to the sine ratio because it has the hypotenuse in the denominator of both, but the cosine has the length of the adjacent leg in the numerator. So the cosine angle or the cosine of any angle is the ratio of the adjacent leg to the hypotenuse. So those are the three trigonometric ratios that we're going to use. We're going to use the cosine and the sine in much the same way that we use the tangent. In fact, exactly the same way we use the tangent. The only difference is which legs that we'll be using within the ratio. So the basics of this lesson then come down to you just memorizing what these different ratios are. SOHCAHTOA is a way that helps us remember these ratios. If we need to remember these ratios, we need to have a way to do it. And SOHCAHTOA is an acronym that uses the first letter of each word in the ratio to help us remember these ratios. The sine ratio is the opposite over the hypotenuse, so if we take the first letter of each word, we have SO. The cosine is the adjacent over the hypotenuse, so if we take the first letter, we have the word, or the phrase, I guess that's not really a word, I don't know what it is, an acronym, CA. And then tangent is opposite over adjacent. Using the first three letters, we have TOA. So SOHCAHTOA is a way that we can use to help us remember what these trigonometric ratios are. And again, that's really the key to trigonometry, at least in the beginning stages here, is knowing and remembering these ratios, and then once we know which ratio, what the ratios are, substituting in the different values to determine the missing one. So let's do a couple of short examples here in writing these ratios, and then we'll do some problems where we solve for the missing length. Write the ratio for the sine of m and the cosine of m. Well, the sine, you remember, the sine of the angle, in this case is m, is equal to the opposite side, so opposite of angle m is the 7, over the hypotenuse, so I locate the right angle, look opposite of that, and so the sine of m would be 7 over 25. The cosine of m is the adjacent side, so again, locating angle m, 24 here is next to or adjacent to angle m, and then the hypotenuse is 25. So this would be the sine of angle m and the cosine of angle m. Now, I would like you to write it out in this format, not just give me the fraction. I want you to write it out because this is the way that we'll be doing it when we actually solve problems, so I want you to practice that now. Let's go ahead and write the ratio then for the sine of m and cosine of m first, and then we'll do the other ones. So the sine of angle m, sine, remember, is opposite, so that's 4 square root of 2 over the hypotenuse, which in this case is 9. Now I would look to simplify this if I could. None of these values simplify, so I'll leave it. And then the cosine, and that looks like an O, cosine of angle M is the adjacent side. So again, here's M, 7 would be the adjacent over the hypotenuse here, which is 9. And then we can do the same for angle L. So the sine of angle L, I look at the opposite, that would be 7 over the hypotenuse 9. And the cosine of angle L would be the adjacent, which would be 4 square root of 2 over the hypotenuse, which is 9. So I want you to notice something real quick. We won't talk much about it this year, but when you get into a deeper study of trigonometry, you'll notice that the sine of M and the cosine of the other angle are the same. And you'll notice that the cosine of M and the sine of L are the same. So it's an interesting thing that happens is that the cosine of one angle is the sine of the other, and the sine of the one angle is the cosine of the other, which is an interesting concept that we'll study deeper when we get into advanced algebra. So one more example, quickly writing the sine of M. So the sine of M, whoops, that's not right. The sine of angle M is, again, the opposite side, which in this case is 2, over the hypotenuse, which is 4. Now this one does reduce, so I'll want to do that. Man, I did that again. I just got that sim on my mind. The sine of M then would reduce to 1/2. I would go ahead and reduce that. The cosine of M would be the adjacent side, which would be 2 square root of 3 over the hypotenuse is 4. And again, this 2 and the 4, which are on the outside of the radical, I could reduce. So this would reduce to the cosine of M is equal to radical 3 over 2. Is that becoming a 2? Now I would write the sine of L. Now based on what I just told you real quickly, the sine of L is going to be the same as the cosine of the other one. So because I've already done the cosine of the other one, I'll just write that as radical 3 over 2. Or you would write it out and reduce it. And then the cosine of L is going to be the same as the sine of the other one, so that's going to be 1/2. Again, you could do that by writing the ratio and the reducing, or just remembering that little fact that I told you about earlier. So that's the sine and the cosine ratio. You now have 3 trigonometric ratios. In the next video, we'll take a look at how we apply these. And again, it's going to be just like we did with the tangent. And then we'll do maybe a word problem or two so you can see how we take these trigonometric ratios now and apply them to real-world situations or real-world problems.